Hello everyone, how is it going? This is part 3 of Computer Networks Fundamentals series. My name is Ahmed Inaya, and in this video I will discuss the concept of IP address. So what is an IP address? Let's start by talking about addresses in general. Let's talk about mail address for example, and we'll discuss the analogy between mail address and IP address. So let's say we have a street, and this street is Rose Street. Let's call it Rose Street. In this street, we have 4 houses, and we will number them as 1, 2, 3, 4. So each house's mail address includes street name, which is Rose Street, and house number, which is any number between 1 and 4 in this case. So if you want to send mail to any of these houses, you need to know street name, which is Rose Street, and house number. So there are 2 parts in mail address, which are street name and house number. So let's talk about the internet and internet protocol IP, which is the protocol we use over the internet. Internet is a huge network that connects devices worldwide to each other. These devices could be laptops, desktops, mobile phones, or even gaming console or washing machine, for example. The main purpose of the internet is communication between these devices using internet protocol. And for devices to communicate with each other, there should be a unique address for each device, which we call as IP address. So IP address is the unique address these devices use to communicate with each other over the internet. So if we apply the same concept of mail address, which is street and house number, we have similar concept in IP addresses. When it comes to the internet, we have billions of devices connected to the internet. These devices need to communicate with each other, and they are grouped into networks the same way we have houses grouped into streets, for example, in mailing system. So let's assume we have these 2 networks. We have network A here and network B here. Each network connects a group of hosts, and let's call them host 1, 2, 3 for network A and host 1, 2, 3 for network B. As you can see here, we can have the same host number in each network, and still it identify different device based on network name. So to identify any device in this setup, we need to know network name and host number to address this device specifically. So each host IP address should include network part, which is network A for example, or network B, and host part, which is anything between 1 to 3 in this setup. For example, this device here is network A host 1, and this device here is network B host 2. And for networks to communicate with each other, we need a special device called router or gateway, and these routers or gateways should be able to communicate with each other over the internet. Before going into technical details, let's discuss IP address operations. For any device to communicate over the internet, it needs to know its IP address. And as we discussed in the previous video, computers talk using binary, 0 and 1s, but this IP address can be decimal and binary, decimal for humans to memorize, and binary for computers to use when they communicate with each other. In addition to IP address, each device should know its subnet mask, which identify network part and host part in IP address, and also each device should know its gateway, so if it wants to send traffic outside its own network, it should send it to gateway, and gateway will transfer this traffic to other gateways or other routers in the internet. When any device wants to communicate with other device in the same network, but when this device wants to communicate with other devices in other networks, it should send the traffic to the nearest router or gateway, and this router or gateway should know all other routers and gateways in the internet and should know how to reach these gateways over the internet. And this is what we called as routing. Let's take an example to describe this concept more. Let's assume we have the same networks, network A and network B, that we discussed in the previous slide. And we have 2 gateways or 2 routers, which are router A here and router B. We have 3 hosts in each network, host 1, 2, 3. So this is a simple view of the internet, but keep in mind we have billions of devices connected to the internet and they are grouped into networks, but this example will make it simple for us to understand the concept of the internet. So first of all, if network A host 1 wants to communicate with network A host 3, which is this communication here between these two devices over the same network, they can send the traffic direct between them, and the traffic can go over the network directly between these two hosts without passing over any gateway. But how about if network A host 2, which is this device here, wants to communicate with network B host 2, which is this device here? These two devices are connected to two different networks, and they don't know how to reach each other because they have no details about the network or the internet between them. So this communication needs to go over gateways, and these gateways should pass traffic between these two devices. So first of all, host 2, which is connected to network A, sends the traffic to router A, which is the gateway of network A. Then router A should find a way to send traffic to router B over the internet, and router B from its side, it knows how to reach host 2 in network B because it is connected to the same network, so it sends the traffic directly to network B. So in this case we have three segments: network A host 2 to router A, and then router A to router B over the internet, and after that router B to host 2 in network B locally within the same network. And for return traffic, it uses exactly the same way. Host 2 network B sends traffic to router B, then router B sends the traffic to router A, and router A sends the traffic locally to host 2 in network A. So after all this discussion, we still didn't identify IP address. What is the length of IP address? What are the components of IP address? Before discussing this, just keep in mind that computers talk only using binary system, which is 0 and 1, and we discussed this system in part 1 of this series. When they started the internet, they decided to have IP addresses as 32 digits or 32 bits in binary system, and this is considered as IP version 4 addresses. Right now we have IPv6 also, but still IPv4 is the most common IP addressing, and when we say IP address, we usually mean IP version 4 address, which is a 32-bit binary number like this, for example. These 32 bits or 32 digits are divided into groups of 8 bits each. This chunk of 8 bits is called as bytes in computer systems or octets. So this 32-bit binary number, which is the IP address, is grouped usually into 4 groups. Each group is 8 bits each or octet each, and these groups in total are the IP address. It is not easy for humans to memorize such a long series of bits or digits, and that's why IP addresses usually are represented as dotted decimal notation or DDN. So for example, this IP address here, which is 32 bits, can be represented as 1010.1.1. So if you convert this binary number into decimal using the techniques that we discussed in part 2 of this series, you will get this IP address. So this IP address here, which is a binary system, is represented usually as this number, which is decimal. And we get this by converting these 8 bits into decimal, and then these 8 bits into decimal, and the same here for these 8 bits and 8 bits. And usually we use DDN or dotted decimal notation to represent IP addresses or to read them as humans, but still computers use binary system or binary numbers to represent IP addresses and to do any operation on IP addresses, like for example finding out network and host part. So how do computers know what is the network part, what is the host part, and what is the gateway for their IP addresses? This is what we'll discuss in part 4 of this series. If you find this video useful, please like, share, and subscribe to receive my future videos. Thank you and have a good day.